Hi, Remy here. In this video, I'll configure the SHT36 V3 board to talk to M8P via the CAN bus interface. And for that, we need to have the Katapult bootloader on the main board. The SHT36 V3, as per Mellow, comes pre-programmed with the Katapult firmware for CAN communication at a rate of 1 million. The Katapult firmware for SHT36 V3 CAN connection has a rate of 500,000 and 1 million and can be pre-programmed to what we need. So if we need to change the rate to 500K, we'll have to flash the SHT36 bootloader. We have to go to this link, BL firmware. It says do not use, but you have to go here and then scroll down and you have to follow this instruction. It says you have to put the device into DFU mode. You have to press and hold the boot button and then with the USB connect it to your computer, and after that release this button. Then the device will appear as a disk, as a drive on your computer, and from there you have to download the file. If you click here, open any of the link, and then here for the SHT36 V3 we have two files, 1 million and 500,000. So we can use this one. So on that disk we have to copy that and you have to follow this instruction. There is nothing much actually. Once you copy it, the file will automatically be deleted, and once that is done, it is confirmed that the firmware is written to the, or the bootloader is written. The other method is host flashing guide. So for that you have to follow this instruction. So I won't be following this since as per Mellow it already comes with the required bootloader. If it doesn't, then I will follow this instruction. To get the CAN bus working, the mainboard STM controller and the RP2040 on the SHT36 must have the Katapult CAN bootloader installed. So I'll be following these steps. First, configure and compile Katapult for the mainboard STM microcontroller. Then configure and compile Klipper for the mainboard. Then flash the Katapult firmware on the mainboard. Then flash the Klipper firmware on the mainboard. After that, configure and compile Klipper firmware for the RP2040 microcontroller on the SHT36 board, and then flash the Klipper firmware on this board. Now, first thing is to validate whether the M8P board already has the Katapult bootloader or no. So for that, we can validate. We'll run this dmesg command. -H is for human readable and W is to read or to get only the new messages. So once this is executed on the M8P board, just press the reset button. So this is the reset button over here. Just press this button and watch the screen. So on the screen, the message output, you will see product STM and the manufacturer, it says Klipper. So this means we have Klipper firmware, and then we can also type the lsusb. So here also we should get as a CAN bus, which means we don't have that. So now let's put this into DFU mode. So to put into DFU mode, we have to press the boot 0 button, which is this one. Press and hold that and simultaneously press the reset button. Okay, now let me run the dmesg command first. So press and hold the boot 0 button and press the reset button and watch the screen. Now the product, it will say DFU in FS mode, and the manufacturer, it says STM microcontroller. Now we'll check the LSB output, LSUSB output. Now here it says STM microcontroller, STM device in DFU mode. So now I'll reset and bring it back into normal mode. Now before we proceed, we have to make sure that we get the Katapult firmware or the bootloader configured properly. We need to pre-compile it. So we'll clone the repository with this command. This command I'll put in the description. Now the cloning is done. We'll change to the repository, and here we'll do make menu config. So from here we have to set the correct parameters. The microcontroller we have to set as STM. The processor will be STM32H723. Then build Katapult deployment application. Do not build, should be left as it is. Clock reference should be 25 megahertz. Communication interface, this should be PD0 and PD1. Then application offset is 128. Then the CAN bus speed, this should be 1 million. I'll leave as it is, the same value. You need to have this value same for the SHT36 board. Since the board firmware is built for 1 million, I'll set this also 1 million. And also in the Klipper, while configuring Klipper, we need to set to 1 million. That will do it later. Then pin nothing over here. And here nothing. We can say quit and save by pressing Y. Then make clean. Then we have to type make to build the firmware. Let's wait for it to complete. So now the Katapult firmware is done. Now we need to compile the Klipper firmware. So we'll change to Klipper directory. Here we need to run the following command to do the cleanup. So we have to remove the config file. So we have to run this command. We are already into Klipper directory. So the Klipper config file we need to remove, and the output directory we need to remove. Then make menuconfig. Now we have to first enable the extra configuration option. So once this is enabled, next we'll select the microcontroller architecture. So this should be STM32. That is this one. Then the processor model should be 32H723. This is for the M8P V2 board. Then the bootloader is correct, 128. Then the clock reference should be 25 megahertz. Then CAN bus interface, this should be USB to CAN bus bridge, USB on PA11 and PA12. Then the CAN bus board, this should be PD0 and PD1. Then ID no change. Now this is the speed which we have to make sure that it is same in all three locations. SHT36 V3 board, the Katapult firmware, and the Klipper should have all the same rate, which is 1 million. Then GPIO, this nothing over here. With save yes, and do make clean, and run make command to build the firmware. Now the Klipper firmware is done, and now it's time to burn the bootloader. So first we have to burn the Katapult bootloader and then the Klipper. So for that, first we have to install the mini jumper. This mini jumper we need to install. You get this jumper with the M8P board. So this should be installed. You can see this header. So we have to install the jumper over here. This is next to the CAN bus port. This is the CAN bus port. Next to that, this jumper is there. So we'll install it over here. Okay, now the jumper is installed. Now next we have to put that into DFU mode. So we'll press and hold the boot 0 button, which is this one, and press the reset button. So I'll run the dmesg command. So now the dmesg command is running. So we'll press and hold the boot 0 button, and then press the reset button. So now here it says DFU in FS mode. Now with USB, we can see that it says also STM device in DFU mode. Next, we need to write the firmware, the Katapult firmware. For that, we need to make a note of this ID. This ID is required to write. So the command for that is this. So sudo dfu-util -a0 -t path to the Katapult bin directory, which was compiled, bin file, which was compiled before, the address, start address, and the ID of the device, which is this one. Then we can enter. So it says dfu error, we can ignore. If it says download done, then this is okay. Firmware is written. Now let's reset the board, dmesg -hw, and reset the board. Now it says here manufacturer Klipper, and lsusb says this output. Now next we have to put the bootloader back into DFU mode. So we'll again press and hold the boot 0 button and press the reset button again. Now we have to write the Klipper firmware. So again we have to make sure that the ID of the device is correct, which is 0483:df11, and the rest remains the same. Just enter. Now download is done. We'll reset the board. Okay, now it says manufacturer Klipper, and we'll check the lsusb output. And now it says here CAN adapter. So now we have successfully flashed the Katapult firmware and the Klipper firmware on the M8P board. Now next we need to connect the SHT36 V3 board. So before we connect the SHT board to the main board, we have to ensure that the CAN interface setup is there. So we can query and see if we have the CAN interface. So we can run this command, and here it gives an error. Please note this commands will be there in the description for reference. This error indicates that the Python environment for Clippy-env, this environment does not have the CAN Python module installed. So let's do that first. So we'll activate the Clippy environment first. Now the environment is active. Let's install the Python module. So next we need to run this command. This will install the required Python module. Now let's deactivate and query the CAN interface again. So this time this error is not there, so we get a different error. Network is down. This basically means the CAN interface is not available, so we need to do that now. Use your favorite editor and create a file that says CAN0 under this directory etc network interfaces.d. So I use bin, and then copy paste this. So here you need to make a note of this value, which is the bit rate. This should match the bit rate or the rate that you have set in the other places, and that is on the SHT board, the Katapult firmware, and the Klipper firmware on the main board. So this value should match. Once this is done, we can bring up the interface. So the interface is up. We can validate that by typing ifconfig command. So this is the interface. And now let's query. So we'll query this. So we have an error over here. We can ignore this. This says that bus type is deprecated. Just ignore this now. What we need to see is this particular line. So it says found CAN bus UUID so and so application Klipper. This means that the main board, Katapult bootloader, and the Klipper firmware is working correctly as a CAN bus. So that is why you are able to see this. Once we connect the SSD board, we should also see another entry apart from this that indicates that the SSD board is able to detect the CAN UUID. If we don't see that, then the SHT board does not have the Katapult bootloader. So then we have to flash the Katapult bootloader on the SHT board. So now this is done. Next step, we'll compile the Klipper firmware, and after that we'll attach the SHT board to the main board. Now let's compile the firmware. We'll type make menuconfig, and now we have to set the parameters over here. We'll enable the extra low level configuration. Then next is to set the microcontroller architecture. This should be Raspberry Pi RP 2040. Then the processor model is RP 2040, which is already selected. Then bootloader offset, this should be 16 KB. Then the communication interface should be CAN bus. Then the CAN RX GPIO pin, default is 4, this should be 1. And the TX, this should be 0, default is 5. CAN bus speed, this should be 1 million. Then the last one, GPIO pin to set at microcontroller startup. This should be GPIO 5 prefix with exclamation mark. So exclamation, then GPIO 5, GPIO 5. Then we can save the configuration. So press Q and Y to save the configuration. Now next we need to type make -J4. Now the compilation is done. Next we will write the firmware. Now that our main board is ready with Klipper, Katapult, bootloader and CAN interface setup done, and also we have prepared the Klipper firmware for the SHT board. Now we need to connect the SHT board to the main board. So for that we have to use the umbilical cord for this one and connect the CAN interface to this port over here. But this should be done using the main power. So we need to use this cable, the umbilical cord, and better to power the board from the main power source over here. So DC voltage you have to put over here, and once you do that, we have to disconnect the USB cable and also remove the jumper. So there is a jumper over here, you can see. So when you are powering the board from here, from this power unit, we need to remove this jumper. So let's do that now. So I've disconnected the power and I will remove this jumper. And then we need to install terminal connector over here. So for this board, I need to look which one is CAN high and CAN low. Let me just look for this and come back. Yeah, okay. So the CAN high is yellow over here. So this will go on this side of the pin. Remember, the driver pins are facing away from me, and this terminal block or the CB one is facing towards me. So in that point of view, this is the pin where I will connect the high CAN. That is, the yellow cable will go over here. So let me get the connector. So you will need this 2.54 mm connector. This connector you will get with the M8P board. So we need to connect this. So this will go like this. You can see there is a lip over here. So keep that lip facing upward, and then we have to install this connector and just slide it in. It will lock in its place, it won't come out, and then we'll install the next one. So now the connector is ready. We'll install it in this board. So over here we need to install, and this jumper we should leave as it is. So we have the connector done. Now I will get the power board connection and all and be back after that. So now the main board, I have connected the 24 volt power supply over here, and the same one I have looped it back to the umbilical cord. So this cord is connected to the same power source that can be seen here. So it goes back to the same location, and also the CAN signal cable is connected. So now let's power on. Okay, now let's wait for this green LED over here to blink. So that will confirm that the OS is If you see here, this LED is blinking now. So that means the board is started. So I will log in now and we'll run the query command again. Now, as you can see here, we can see it found two CAN bus UUID. The first one is for the main board and the second one is for the SHT board. So this confirms that the SHT board comes preloaded with the Katapult bootloader. Now we have already compiled the firmware, Klipper firmware for the SHT board. So we have to burn it on this board. So before that, we need to notice one thing. The LED, if you can see here, this is now blinking, blue LED is blinking. So once we have the firmware installed, this should stay solid on. So it should not blink after the Klipper firmware is flashed. Second thing is, since we are using CAN over here, this dip switch need to be in the top position. It's in the bottom position now. So let me do that change. So now if you look at this switch, dip switch, it's in the top position now. So now we can flash the Klipper firmware on this one. So before we start to flash the firmware, make a note of this UUID both for the Klipper and the CAN board, because once you flash the Klipper firmware, this name will change from CAN board to Klipper and then we'll get confused which one is what. So we need to make a note, as we need to modify our printer.cfg file to use this UID in as a MCU. So we'll copy this now. Okay, now that is copied. Now next is to flash the firmware. So you have to run this command. Over here, you have to make sure that you use the same interface as we had configured earlier, CAN 0, this one. And the UID should be of the CAN boot, which is this one. Since the firmware that we compiled is for RP2040, it should match. So this is what is there for the RP2040, this UID. The same UID we must put here. And then we can flash. Now flashing is done. So we'll query again. So if you look here now, this is changed to Klipper. So we need to make sure that we identify the UUID correctly. So that is why we had to copy this in the previous stage. So next step, we have to restart Klipper. You can reboot or restart. Now Klipper reboot is done. We have to go to the main cell interface and do the required changes. So this is the main cell interface. Just ignore what you see over here. Go to machine and then printer.cfg. And you will have your MCU section. Mine is defined in this file. So I need to change over here. Close this and then open this file. And down over here, MCU serial is there. So this is because before we burn the Katapult boot firmware, it was reading as serial. So after we wrote the Katapult firmware, it has changed to CAN bus. So we need to use the UUID here. So we can copy this one now. So this is the UUID of M8P STM microcontroller. And then the second entry will be for the toolhead. That is this one. So this is a temporary setup. So I'll just put it over here. So this UUID is for the SHT36 V3 board. And this UUID is for the M8P STM microcontroller. And this one we need to delete, or you can comment. Then save and restart. Okay, now the MCU is detected. It says the ADC out of range. You can ignore this. This is because I do not have any temperature sensor connected. Now if you see here, now this LED is solid blue. Now it is steady. It's not blinking anymore. So that means the Klipper firmware is running now. Now I have connected the thermistors. This is ATC thermistor, which is connected to the main board on THB port over here. Then on this hotend, there is NTC thermistor, which is connected to toolhead board on this particular port. And This is 24-volt fan, which is connected to fan 0 port over here, and also have installed this jumper on the header pins. That is the very first tool, which is for VCC. So now we'll go to Klipper and see the configuration, and then we'll check the temperature sensor and the fan. Now under extruder, I have defined the sensor pin to be referenced from the Toolhead board. This is the name that I have given for the Toolhead MCU, and the general purpose IO pin 27. Then under heat bed, sensor type ATC, and under fan, again the pin is referenced from the Toolhead board, which is named as SHT36 V3, and the GPIO pin is 13. So we'll go to the main dashboard. Now here we can see it is reading the temperature, extruder and heat bed. Now with my thumb, I'll just hold this ATC thermistor, and if you notice on the Klipper dashboard for the heat bed, the temperature is rising. Now we'll go to the fan section and we'll turn on this fan, which is this fan, 24-volt connected to the Toolhead board. So we should see the fan coming on. Okay, the fan has turned on at 50%. We'll go 100%. Switch off now. So now I have done this testing. So thank you for watching this video. God bless and stay safe.